Leetcode 239, Sliding Window Maximum. Given an array and window size k, return the maximum in each sliding window of size k. Example, nums as shown, k equals 3. We slide the window and show the maximum for each position. Output, 3, 3, 5, 5, 6, 7, the maximum in each window of size 3 is 3, 3, 5, 5, 6, 7. Approach, monotonic deque. Variables, deque is a deque of indices, we keep it so values at those indices are in decreasing order, so the front is always the current window max. Result is the list of maximums we output. Steps, for each index left to right, pop from the front while the front has left the window, pop from the back while the value at the back is less than or equal to the current value. Push the current index to the back. Once we've seen at least k elements, append the value at the front of the deque to result. We use a deque, front on the left, back on the right. We process each index from left to right. At each step we may pop from the front if that index has left the current window, and from the back we pop any index whose value is less than or equal to the current value. They can never be the max. Then we push the current index to the back. The front of the deque is always the current window maximum. Now we process each element of the array. First element, value 1 at index 0. The deque is empty, so we push it to the back of the deque. Second element, value 3 at index 1. Value 3 is greater than 1, so we pop 1 from the back, it can never be the max now. Then we push 3 to the back. Third element, value -1 at index 2. Value -1 is smaller than the back, so we push it to the back. We have now processed the first k elements. This is our first window of size k. Fourth element, value -3 at index 3. Value -3 is smaller than the back, so we push it to the back. Window max is 3, we add it to output. Fifth element, value 5 at index 4. Index 1 has left the window, so we pop it from the front of the deque. Value 5 is greater than -3 and -1, so we pop them from the back. Then we push 5 to the back. Window max is 5, we add it to output. Sixth element, value 3 at index 5. Value 3 is smaller than the back, so we push it to the back. Window max is 5, we add it to output. Seventh element, value 6 at index 6. Value 6 is greater than 3 and 5, so we pop them from the back. Then we push 6 to the back. Window max is 6, we add it to output. Eighth element, value 7 at index 7. Value 7 is greater than 6, so we pop 6 from the back, it can never be the max now. Then we push 7 to the back. Window max is 7, we add it to output. Done. The maximum in each window of size 3 is 3, 3, 5, 5, 6, 7. What does leaving the window mean? The window is k consecutive indices. As we move right, the window slides and its left boundary moves. An index has left the window when it is to the left of that boundary, it is no longer inside the window. So we pop it from the front of the deque because it cannot be the maximum of the current window anymore. Time is linear in n, each index enters the deque once and leaves at most once, so total work is O, n. Space is O, k, for the deque. In the worst case when the array is strictly decreasing, we hold k indices. The output array is O, n, but is usually not counted as extra space. Pseudocode for sliding window maximum with a monotonic deque. We maintain a deque of indices in decreasing order of value, the front is always the current window max. Initialize empty deque. For each index I from 0 to n-1. While the front index has left the window, pop from front. Pop from front of deque. While the back value is at most nums, I pop from back. Pop from back of deque. Push I to the back of deque. If we have a full window, append the front's value to result. Append nums at front of deque to result. Return result.